All right, so our final topic for this portion of the course, we're going to talk about what I refer to as the range of likely outcomes. This is not a topic that you're going to find in every textbook, and when you do find it, not everybody agrees on the exact definitions. The idea is, in any population, if we choose somebody at random or something from random, we'd like to have a pretty good idea of kind of what to expect. So if we're looking at, again, heights of people, if we pick somebody at random, we know that very likely they're going to be between, say, 5 foot and 6'3" or something like that. Anything outside of that range we'd be a little surprised by. So anything outside that range we would consider to be unlikely. So in any situation we're looking at, I want us to be able to identify, what our sort of likely or expected outcomes would be versus what would be surprising or what would be unlikely. So I have referred to a range of likely outcomes. ROLO for short, that's not an accepted statistical term. But for any situation, we want to be able to identify the range of likely outcomes. And what we mean by likely is that that's what we're going to end up with 90% of the time, 95% of the time, excuse me. So going back to our empirical rule, right, we know that 95% of the population falls within 2 standard deviations of the mean, which means that 95% of the time, if we were to select somebody at random from the population, they would be within 2 standard deviations of the mean. So that's what we're after here. The range of 1 standard deviation, 2 standard deviations below the mean to 2 standard deviations above. So if we're talking about IQs, the range of likely outcomes would be, we know the mean is 100, we know the standard deviation is 15, would be from 100 minus twice 15, which is 70, to 100 plus twice 15, which would be 130. So our range of likely outcomes for IQs would be from 70 to 130. Meaning if we grab somebody at random from that population, 95% of the time, they're going to come from that range. The reason we want to know this is if we do get somebody outside of that range, especially if we get people, if we choose like 3 or 4 people and they all fall outside of that range, we're going to have to question whether or not this information is actually correct. Let's take a look at heights. Said before, the average height for American males, 5'8". For females, it's a few inches less than that, and the standard deviation is a few inches less also. I don't remember them right at the moment. So 5'8" with a standard deviation of 4 inches, which means that 95% of the time we're going to fall within twice this of the mean. So if we double 4, we get 8. If we take 5'8" plus another 8 inches, that's going to be 6'4". If we take 5 foot 8 inches minus 8 inches, that's easy. That's going to be 5 feet exactly. So 95% of the population falls between 5 foot and 6'4", which I think earlier I said 6'2", I'm not sure. Or another way of saying it, 95% of the time, if we select somebody from at random, they're going to fall within that range. Okay, same thing every time. All we have to do to calculate the ROLO, range of likely outcomes, is to start with our mean and our standard deviation. If we double the standard deviation, here that would be 7. This is whatever. This doesn't come from anywhere, just random numbers. So we double the standard deviation, subtract it from the mean, add it to the mean, 34, and that gives us the range of likely outcomes where 95% of the population lives. So if we pick somebody from the population, 95% of the time, they're going to fall within that range. And again, that doesn't mean it's bad if they fall outside of that range. It just means we might be surprised by that, especially if it happened over and over again. We'd have to look at what we were doing. And this is going to become a very important idea at the end of the semester. The last 2/5 of the semester are going to be based very much on this idea. I will talk to you again soon.